Hey folks, greetings from the Offensive Security Group here at Secure IT 360, coming at you with a new episode of the Cyber Threat Perspective. Today, I've got Darius on the podcast again. Darius, how's it going?
Hey, doing good. Glad to be back.
Yeah, awesome. So in this episode, we are going to be talking about how to identify and mitigate insecure Windows services. This is a very common issue that we see on internal pen tests. I also wrote a blog post about this and published it in February of this year. So if you're listening to this episode, go check out the blog post after you listen to this episode. That's got screenshots. It's got detailed kind of step-by-step instructions on all the things that we're going to talk about in this episode, how to identify these misconfigured services, insecure services, and how to mitigate them. And I have some tips for defenders on using a specific tool to kind of do the identification of these insecure services at scale across your environment. So I've got a really cool tip at the end of that blog post, so go check that out. So before we get started into this, I just want to mention that this is very common, like I said, on internal pen tests. And the reason we find it so often is kind of, I guess, how we do our internal pen tests. We do an assume breach style of engagement where you give us access to a compromised host, right? And that's where we start the engagement from. Traditionally, a lot of internal network pen testing would be, we deploy a machine on your environment and we start unauthenticated. We just start scanning and poking around and see how we can maybe get access to a credential on the network and kind of move from there. But what we do is we assume that a user is going to click on a link or get compromised. And so we start with a domain user account on a domain system or whatever your endpoint looks like. So day one of our internal pen test revolves highly around an endpoint evaluation is what we like to call it. It's an endpoint security and configuration evaluation. We look at applications and services and tasks and the software that's installed, the security configuration and everything in between to look at, are there any misconfigurations that would allow an attacker or a bad guy to kind of continue their goal, whether it's to get credentials or to move laterally, maintain persistence, etc. So in doing that evaluation, this is something that we see very often. So that kind of sets the stage for this episode, Darius. I do want to just briefly talk about services in general for those who are maybe not super technical or in depth, or maybe just as a refresher for people what a service is. So I'll go first and talk about a few things, and then if you want to jump in and talk about services, please go ahead.
Yeah, that works.
So a service to me is just a program that runs in the background, right? There's no GUI for it. There's no interface. It just runs in the background on Windows, and it performs a specific task. It depends on the software or the program that's running as a service, what it does. But that's essentially what a service is. It runs in the background. It can start and stop automatically, and it does some operations or some action on the system. Darius, what else about a service you think is important to know?
Yeah, so I think also with services, a lot of times, not in all cases, but a lot of times what we'll see is they tend to run as an elevated account. So they tend to run a system, which I think is pretty huge, which I think leads to some of the other things you're going to talk about. But I think additionally, I mean, you hit the nail on the head, right? They run in the background. They're your typical things such as, like, I'm trying to think what's a good service. I can't think of on the top of my head. Print spooler, for example, is a service that you may find running on your computer because how else are you going to print, right?
Yep.
So yeah, I think we use it all the time, but it's one of those things that, especially end users, they're not really going to see,
Yep.
if you're doing it right, they're not going to see it, nor are they going to really know about it.
Exactly. Yep. So print spooler is a good one. There's a fax service on Windows. If you ever looked, there's a DHCP client service. There's services for a lot of things. And like you said, Darius, exactly. A lot of those systems run as the local system account or some sort of other, built-in service, like a network service for a lot of the networking stuff. And the important thing to note about this discussion is those services can run as domain accounts. They can run as local user accounts, like a local admin account or a local user, Or, like we said, they can run as a system account. And that system account is an important point because as we get into this discussion, we're going to talk about what the system account is. But essentially, it's a built in account in Windows that can pretty much do anything, right? It has elevated privileges in the environment. And so when attackers are, moving laterally, or they're performing code execution, or they're trying to run a beacon or something like that on an endpoint, using the system account is a good option for that because it has the highest privileges. So that's why it's kind of a target. So that's kind of what a service is in the system account and why that's important. Uh, I want to talk about briefly kind of the root cause of these issues, and then we'll get into some of the common misconfigurations. So the two that I've seen, Darius, and I don't know about based on your experience in doing IT admin work, even or on pen tests yourself, the two that I see is kind of the root cause of these is the product installation. That's a big one, right? So the product either installs itself, insecurely. So when the installer runs, sets all the files up and moves everything, creates a service, and then for some reason the product says, oh, well, all users need to be able to write to this directory, or all users need to be able to restart the service or configure the service or something like that. That's something I see a lot. I don't know if you've seen this in your IT admin days or even on pen testing, right, where the product gets installed improperly.
Yeah, so you see that a lot. And I really, like I say, it really just comes down to how the developers, wrote the application and how it installs. I think it's also a thing where, I remember back during the IT days, it's also something that we weren't really considering. It was like, hey, we purchased this product, we just need to push it out, install it, right? So it's
Right.
one of those, you're not really checking for some of these installation or insecure installations and things of that nature. I think something else that kind of really stands out to me is, if I can get personal a little bit, is I remember when I was first kind of starting on my pen test kind of journey a couple of years ago, and I was doing like try hack me boxes and things like that, and I can't remember the specific name of which one it was. It may have been Kenobi, not sure. But this exact thing was kind of the big deal with like, hey, this is how you're going to Privesc,
Yep.
is basically through a service. And so it was kind of crazy to see that in a lab, right? And like, okay, cool, you did something on Try Hack Me, but then to finally, become a penetration
Yep.
tester, start seeing some of this stuff, and it's like, oh, this is happening in the real world.
Yep.
And to your point, it's more common than you think. That is, just kind of blew my mind.
Yeah, definitely. And it's like you said, it's pretty much a de facto standard to have in pen test training courses. As you can see over here, like PNPT, the RTO courses both feature, Windows Privesc in the sense of of training, in that they cover insecure services among other things. So, like you said, it is like a de facto standard because it is so common. And it's so common because a lot of software installs itself incorrectly. It will install itself to the root of C, or it will install in program files, but it will configure the permissions on the parent directory to be insecure, to like allow everyone to modify files within that directory. Or it will even misconfigure the service, and the service will have something called service all access, which means full permissions to modify the service. And this is really poignant because I'm doing a pen test just this week where I have this exact issue, right? And it's a twofold issue. And we'll, as we get into the common misconfigurations, remind me and I'll talk about that in more detail. But this is something we see very often on our pen tests, and it's the reason why it's incorporated in a lot of those pen test training courses, is because of a very common issue.
Yep.
So the other one, the other common root cause, and you kind of alluded to it, right, is administrator error, right? Time and time again, you've probably seen or heard people say, well, that's just the way it needs to be done, or that's just how it has to be configured, or that's how the vendor said to do it. So it might not be a misconfigured installation. It might be admin is reading the documentation, or they have some sort of requirement that says, all users need to be able to write to this log file or drop files here. So they need permissions on this folder, and inadvertently, cause this issue to occur. So admin error is a big one. that we see often. And I guess there is, you and I both know, and everybody listening, a lot of security issues are the result of admin error, right? Unfortunately,
Sure.
it's just the way it is.
And it's tough because you know what it's like we purchased it, we gotta deploy it.
Exactly. Yeah, and on a pen test a couple weeks ago where we found an issue similar to this, it was a little bit different. It's a modifiable startup app, right? And the application installs itself, and then it puts the path to that file in the system path, right? But it also changes the permissions on that directory to allow all users to write to it. So you have a writable system path as a low privileged user, which can again allow you to elevate your privileges locally. And, in speaking with IT people, they're like, yeah, that's just how the vendor has their product configured. Like if we change this, the product won't work. It will break. Like we can't fix it. So there are things like that too that, are kind of admin error, but they're not really. They're requirements from the vendor. But the point is some, to no fault of anybody, right? It's not blaming anyone, but there is admin error involved in a lot of these issues that we see related to this.
What I'm hearing is that it's a developer thing. Develop your products to be installed securely.
Yeah. Yeah. Yeah, for sure. I mean, I would say a good 80%, 70 to 80% is just the product is built in a way that it gets installed, in an insecure way, or, it's required to be installed or required to be configured in an insecure way. All right. So the common misconfigurations. And in the blog post, this is, like I said, detailed step by step. There's sections for each of these and how to find it. And there's some PowerShell syntax that you can use to quickly identify these on your system. So go check that out after you listen. So first one, unquoted service paths. Darius, you want to take a crack at explaining what this is?
Yeah. So essentially, from my understanding, and you probably have to correct me on it, right? So whenever a service path is kind of listed, if it's not quoted, that pretty much means that you can manipulate it and potentially put your executable in a certain spot, and so that it gets loaded instead of the actual service. And so that's kind of the gist of it, from my understanding.
Yeah.
I'm sure you probably have a little bit more to add to that.
Yeah, no, that's exactly right. That's how I would describe it too. Is so when Windows services have a path. When you configure the service, it requires a certain binary to run. So there's a program that runs, and that program lives in a certain directory on Windows. So like C program files, my program.exe. In the service configuration, like you were saying, if that path includes spaces in the name, so like C program files has a space between program and files. If that path has spaces anywhere in it and it's not wrapped in quotes, because of the way that the search order works in Windows and the execution order works in Windows, it will look in each of those directories that have spaces in them for that binary that's being run. So that program, that exe file that's being run, it will look for it in each of those places in the path if the path is not wrapped in quotes, so double quotes. So that's exactly what the issue is. And this is very common, even with built-in Windows services sometimes, or third-party services like Intel and like your audio drivers, third-party, third-party software like document management systems. And what's an example? Trying to think of other software that I've seen that I can call out. I've seen PDF products. I've seen document management system products like document comparison files. Seen PDF readers and audio drivers and you name it. There's a lot of examples of this.
And it's gotten to me, it puts me in the mindset, and it's not 100% one-to-one match, but it is kind of similar to DLL hijacking, where you're making use of you're taking advantage of the fact that, okay, we're going to look here, in these places first, and if you can basically get your executable or malware or whatever in that to be listed first, then boom, you'll get it to run. And in this case, if it's a service,
Yep.
a lot of times you can get it to run as system.
Yeah, exactly. And in the blog post, I have a nice diagram or a nice screenshots that kind of highlight where the execution happens and stuff like that. So go check the blog out to kind of see what this looks like in practice. But unquoted service paths are probably the most common that I see. And that is easily identifiable. It's super easy to run like a PowerShell command. You could use like get WMI object to list all the services that have spaces but no quotes. And there's a number of ways to identify this. And even things like possibly Nessus might find stuff like this. So if you're able to do an authenticated scan of your systems, Nessus should find this one. Some of the other ones we're going to talk about, maybe not. They probably don't find that, but this one, hopefully vulnerability scanners are probably pretty good at finding this. So the next one, and I guess we should talk about, how to fix this one. The fix is to put it in quotes. So since the path, an unquoted service path, it's called, doesn't have quotes around the service path, so the path to that service program, the fix for it is to just modify that service so that the path is wrapped in double quotes. And that's simply the fix.
And I really like that because, it's something that even if the product ships insecurely, you can still fix it. You as an IT personnel can still fix it and nothing should break.
Yeah, exactly. This one, like you said, it should be no impact to the functionality of the program. So the next one is insecure file folder permissions. So the way this manifests is, let's say we have a program and it gets installed to like C program files, my program /myprogram.exe. In that my program root directory of program files is maybe configured with permissions that allow, the everyone group or authenticated users to modify that directory or the files in that directory. So this could be a misconfigured folder, like I just described, or it could be a misconfigured file. So maybe the binary or the program that the service is running with, like the actual service program that's running, has misconfigured permissions on it as well. Maybe it has modify permissions on that program. So there's two kind of different flavors of this, but essentially the same thing. And it comes down to misconfigured permissions on either a file, being the program, or the folder and the directory of that service.
Yeah, and I think this will get you in a lot of cases, not just in terms of what we're talking about, but I think this also kind of puts me in the mindset of if you have scheduled tasks and you're able to, and you have, wherever the scheduled task is pointed to, same, very similar concepts where you can then go and if you have the permissions, either replace a script that's being ran by a scheduled task or an executable or anything like that with something that you've created.
Yep. Yeah, definitely. Scheduled tasks fall into a very similar bucket here with having these issues for sure. So this one, insecure file folder permissions. Again, this is a permissions-based thing. So you want to use tools that can look at the permissions of the programs that are installed on the computer. And you want to look at Windows programs and third-party programs. So like built-in stuff and third-party stuff. And essentially you just want to look at the permissions of program files, right? So you go through all of the program files and you look at all of the permissions of all of those directories and all those files. So there's a number of tools you can use to identify this. One of the easiest ways is to use a tool called Access Check, which is part of the sysinternals suite of tools. It's a legitimate Windows tool. You can also use a built-in tool called iCackles. That's how I say it. I don't know if anybody says it differently. ICACLS, which is a permission tool to view and list and modify permissions. So you can use Access Check or iCackles or anything else, get ACL and PowerShell to look at the permissions of those. This one for identification can be a little bit tricky because you want to look at not only the file permissions but also folder permissions. So you kind of want to look at the permissions in a recursive manner, like from the parent directory all the way through to the program itself. But this is not, an impossible task. It's very straightforward to identify.
Now, I will
Um,
say this one's can be, from my understanding, this one's can be a little bit tougher to kind of mitigate because you do run the risk of, like we were talking about earlier, um, what if the application or the service just breaks because I've
yeah.
changed permissions? So this one can be, I think a little bit tough to kind of mitigate, but I do think, it's kind of playing the whack-a-mole game of permissions until you get it right.
Yeah, definitely. And like you said, yeah, so maybe that program requires all users to be able to write to a certain directory, and that directory just so happens to be where the service binary lives. Well, maybe you can't modify that or change those permissions in any way. So you're right, that can be kind of tricky to remediate. But to your point, that the remediation for that would be to audit those permissions, and if there's a need for that, document the reason for that, and make sure that's known, um, and maybe try to work towards remediating that with the vendor, or fix the ACLs, remove those unnecessary permissions from that directory or from that file, so that all users can't just modify it and then use that to execute unprivileged code. So the third one is kind of related to this, and both of these two kind of tie into that story I wanted to say about tell about the pen test this week and previous weeks. But the next issue is insecure service permissions, and the service permissions are different from the file and folder permissions. So when I say service permissions, I mean the actual permissions that have been granted to the service. So you have a service like my program, that's running. Not only does that program live in a certain folder in a certain directory on the Windows file system, but that service itself also has permissions. So you can give users different permissions for that service. So you can give permissions to modify the service or restart or stop, or any number of different permissions that you can grant on the service itself. And you can even grant full privileges, which is called service all access, which is the highest level of privilege you can give to a service or to users to modify a service. So insecure service permissions issues arise when the service itself has misconfigured permissions. So maybe myprogram.exe has permissions such that all users are able to modify the service, which means that me as a low privilege user without admin rights can modify the service so that I can replace the program that's being run with my own malicious program that I want to execute. And that can be dangerous for obvious reasons because, like we said earlier, a lot of those services are running as system. They could even be run as a domain account. I've seen that as well. But that is kind of the core of this issue. So this one kind of ties into that story. Was that I was on a pen test just this week where I found kind of a combination of these issues, and it was insecure file folder permissions and insecure Windows service. And it's important that when we're doing pen tests, it's important that when we're doing this, we're evaluating environments that we discover the root cause and the full scope of the vulnerability, right? So there was two parts of the vulnerability. So let's say let's say we only find the file and folder permission issue. Client fixes it, everything, think everything is good, but there's still that underlying service permission issue that would be, still there. So just kind of a little tidbit for those who are pen testing or looking at these issues is, make sure you look at the full scope of the issues and don't overlook things and think things are fixed without looking at the whole scope of it. In this case, the fix would be to fix the file or to fix the folder permissions and change the service permissions so that all users can't modify it. So kind of a combo issue that I saw this week, and I've seen that before as well.
And not to derail too much, but I think you said something pretty significant, and I think it's something that I think we all, when we're first kind of starting out with pen testing, or you're interested in ethical hacking, you're learning all this stuff, is the natural inclination is to jump straight towards the let's exploit stuff. when really what's really powerful and what will leads often leads to more success is the more due diligence you do and put on your recon and just information gathering,
Mhm.
pays huge dividends as you kind of go through the process.
Yep. Yeah, exactly. And, a lot of that depends on, your methodology, to use a kind of a pen testy buzzword, your methodology and your enumeration skills. So if you see that there's a program that has misconfigured permissions, right? Or you find a directory that has a service with insecure file folder permissions, you probably want to look at the other possible issues that could arise with that thing. So you probably want to look for unquoted service paths. You want to look at the service permissions. You want to look at it in totality instead of just focusing on that one thing, like you said, and then exploiting that and then screenshotting it and calling it a day. You find an issue and then you want to discover what's the full impact of that issue, right? So you got to look at unquoted paths. You got to look at the service permissions. And kind of look at it in incompleteness there, if that's a word.
Yep, for sure.
So those are the three most common insecure service misconfigurations that we see: unquoted service paths, insecure file folder permissions, and insecure service permissions. Kind of again, the blog post has really good screenshots and descriptions of all of these. So I definitely encourage you to kind of go and look at the blog post to see what this looks like in practice if you haven't seen it before, and read about it, because it's a very interesting issue. It can be very hidden. Like I was saying with the unquoted paths, Nessus is pretty good at finding unquoted service paths. I've seen Nessus report on that. I haven't necessarily seen them report on the other two, which is the insecure file and folder permissions and the insecure service permissions. So that really is going to come down to like a endpoint evaluation or a pen test, or it's going to require you to actually go looking for the issue. So it's important that when you're doing vulnerability assessments or penetration tests, that you are doing a endpoint review to make sure these kinds of issues aren't kind of laying in the weeds and kind of lurking around hidden in the environment, because these issues can be pretty tricky and pretty sneaky. And the permissions are not always straightforward. It's not always just everybody has all right access or whatever. It can be quite tricky to kind of evaluate and to validate, and prove that there is an issue there.
I know some
But
other tools to kind of look for this too. I know they're outdated, but I look at WinPeas. WinPeas is also another tool that you can run that will also kind of at least identify, like, hey, like you said, unquoted service pass, for example. It's possible doing that as well.
yeah, definitely. There's a lot of great tools, and if you run WinPeas, turn off your AV before you do it, because it will get flagged.
For sure. Yeah.
It's definitely signatured. But there are other tools as well that are kind of in that pen test realm, like PowerSploit has from 9 years ago or 10 years ago now, has a Prevesc check script that can look for a lot of these issues. And there's a lot of other tools too that you can use that are free that will help you identify this, or even just writing up some custom PowerShell code to look at the permissions of the services and things like that can be helpful. And like I said, in that blog post, there is a really cool trick or a tip, I guess, about using this one tool to kind of check all of your systems at scale for some of these issues. So I find it was a really good way to do it. I've used this product in the past at my last job, and I love it. And I know a lot of other IT admins use it as well. So it might even be something you have already. So definitely go check out the blog for that. It's on offsec.blog, and it's called Hidden Danger: How to Identify and Mitigate Insecure Windows Services. We'll put a link in the show notes as well for people who want to check that out. So anything else related to insecure Windows services, Darius, that we missed or we want to talk
I
about?
think pretty much, yeah. I think we covered it all.
Awesome. Cool. So that's all we have time for today. Again, if you enjoyed this episode, if you got value from it, if you're liking the content that we're putting out, we would appreciate if you subscribed and kind of follow the show. That helps us reach more people. but also share it. If you want to share it on LinkedIn or Twitter or wherever you network with people, if you got value from it, please share it. Let other people know about it, and that's the best way you can help us. You can check us out on offsec.blog and at secureIT360.com, and we will see you all next Wednesday.